Okay, this is Unit 1, Lesson 4, Part 2. This part is going to be all about finding the distance of things between 2 points. There's going to be a very important formula that I'm going to teach you called the distance formula. Like I said in Part 1 of this video, something that you're going to have to commit to memory. Okay, we got another one of these kind of thinking questions that want you guys to answer. I am at mile marker 24 on Interstate 95, and she is at mile marker 62. Again, whoever this mystery girl is. How far away does she live? So think about how you would go about finding the distance between those 2 places. So again, I'm going to want you to write this down on a separate sheet of paper or in your notebook. And I'm going to go on to the next page of your notes. So this example of distance is a straight line distance. Here we're going to talk about distance on a coordinate plane. Okay. So we have, I live at 7.5. So x7, y5 is here. And my friend lives at 2, x2, y-4 is here. Okay. And it's asking us, what are the distance between those 2 points? So again, just like in part 1 of this video, you kind of can't count in the diagonal direction. But one thing I want to point out to you is that the distance between those 2 points, and we're just talking about the distance, right? If we imagine the coordinate plane as streets, one way we could get to one point from the other is we could go in the x direction, this much, okay? And then we can go in the y direction, this much. So the x direction from 2 to 7, that's 5. And then in the y direction from -4 all the way up to 5, that's going to be 9. Okay. So that's kind of a way I want you guys to think about it for now before I give you the formula. So we got these 2 points. And then, if you guys notice, if we wanted to close this shape, what kind of shape would it make? Well, if we drew a point, the shortest distance between 2 points is a straight line. If we drew a straight line from this point to this point, we got a triangle. Okay. The only problem is we can't count because it doesn't go evenly across the grid. We can't count the diagonal. So we're going to have to figure out some other way to find it out. And in comes the distance formula, which you guys have at the kind of below the graph on your set of notes. So I'm going to write it up here. Something you're going to have to commit to memory. We got the square root, a big square root, x2 minus x1. So that's just how far is it from the x's, plus squared, plus y2 minus y1. How far are the y's squared? Okay. Now, because I already counted for you, I'm going to skip the part where we plug in the actual coordinates. I'm going to show you that in another example. So we know that the difference in the x's. So the difference in the x's and the difference in the y's is what we need to know. Well, I already told you. The difference in the x's from 2 to 7 was 5. And from -4 up to 5, well, that's 9. Now we can just solve this. We got the square root. 5 squared is 25, plus 9 times 9 is 81. 25 plus 81, that's going to be 106. And if you put this in your calculator, you will get a decimal, so you can just leave it like this. This is your answer. Okay? This is an exact answer. If we wanted to know how far away it was and we wanted to estimate, you could put this in your calculator. Square root of 106 and you would get 10.29. Let's just say 10.3. So that's how far away we are. So if we had plugged in the points for y, so we got y2, if we look at our points up here, we got y2 is -4 and y1 is 5. Right, so we would have had -4 minus 5, which would have been -9. Now, why didn't that matter in the end? Well, two reasons. One, first reason is, even if you have a negative number in the parentheses, you're always going to square the number, so it's going to turn positive. If we had -9 times -9, that still equals 81. So that doesn't matter. But the more important thing to take away from this is, and I'm going to write this in big letters, the more important thing to take away from this is we're talking about distance. Okay, we're talking about distance. And I will give you an A for the year, the whole year, you don't have to do any work, if you could take me outside of the track and you can run a negative mile. Okay? Even if you run a mile backwards, that's still running in a positive direction. So the idea here is that distance is always positive. Right? There's no such thing as a negative mile. There's no such thing as negative inches, negative centimeters. Anytime you're measuring something, it has to be positive. It has to exist. So distance is always positive. That's the important takeaway from this. I'm going to do one more example where I plug in the points that they give us. What are some other words that could be used to find distance? So they might ask like how far, for example, or you gotta write down any that you think of, or what is the length of something, because that's just measuring between 2 points. So these are some examples of some questions that you might see where you actually have to use the distance formula. So let's do one example where I plug in the points. I'm going to write the distance formula at the top. So you have it. Square root x squared, x2, not x squared, x2 minus x1 squared plus y2 minus y1 squared, all under the square root. So if we were to label our points, we got x1, x2, and then we got y1 and y2. Sorry, that's so small. So now, let's plug it all in. So we got our big square root, we got our parentheses, and our square plus parentheses squared. So we were going to plug in the x's. So we got x2 minus x1. They're the same, so it's going to be 2 minus 2. And then y2 minus y1, well, y2 is 5. And y1 is -1, so minus -1. Okay, so we got 2 minus 2, and we got 5 minus -1. Well, that's going to be 0. And 5 minus -1 will turn to 5 plus 1, so that's going to be 6. So 0. 0 squared is just 0, so I'm not going to write that. But 6 squared, 6 times 6 is 36. Okay, and the square root of 36 is 6. So this kind of undoes itself and goes back to just being 6. Now, I labeled x1, y1, x2, y2 for you, but if you wanted to, you could label it the other way. So we could have said, it's not going to matter for the x's because the x's are both 2. But if we change the order for the y's, so if we had 2, it's still going to be 2 minus 2 for the x's. But if we said 1 first, negative 1 first, so I'm going to change this to y2, and I'm going to change 5 to y1. Negative 1 minus 5 squared. Well, you can see we're probably going to what? Get the same thing again, right? So we got 2 minus 2, 0 again. And then we got negative 1 minus 5. That's negative 6 squared, right? And then you can see that this is going to simplify into, so negative 6 times negative 6 is still positive 36. Distance is always positive, so it doesn't matter which order you write the points in. You just have to do, if you label the first point x1, you have to make sure you do y1. You can't switch it. You can't do x1, y2, and x2, y1. Okay? But we're still going to get the square root of 36, which is just 6. So I did all that to say that the order doesn't matter. Like you could do either, you can make the first point x1, y1, or you can make the first point x2, y2. You still should come out to the same answer. Okay? Now, I think you guys can do the rest of this on your own. I want to go to the last page and just give you some hints. Okay, so the thing that you need for the map is that you have to figure out the coordinates. And once you figure out the coordinates, you could find the distance, because the question is find the distance. So if we look at number 7, Oak Station is on the blue. Well, so is Jackson Station, but Oak Station is here. That is negative 1, negative 2. And then Jackson Station is going to be 2, 4. So now that you have the 2 points, you can find the distance by plugging them into the distance formula. Okay. The only other one that you might want to pay some attention to is number 11, where it has Maple Station is 6 miles west and 2 miles north of City Plaza. Maple Station is not on the map, so you're going to have to plot it on the map to figure out where it is. But City Plaza is at 0, 0. It's at the origin. So it should be pretty easy to find out where Maple Station would be. But 6 miles west and 2 miles north. So you need to go left and up and plot it on the map and then get the coordinates. Okay. Number 12 on your paper is bringing midpoints back. So again, you're going to want to find all the, or they give you the coordinates for A, B, C, D. You want to plot them on your graph. Find the midpoints of AC and BD. And you don't have to, all is that for question B is just asking what appears to be true about the diagonals of the parallelogram. So if you look at it, what are the diagonals? So from opposite points, what seems to be true about those? So I want you all to finish the rest of the problems on your own. Please ask if you need assistance and bring it to me to check when you are done. This is the end of Unit 1, Lesson 4. Peace.